Something unprecedented has just unfolded in deep space. An event so sudden, so baffling, that every astronomer who's been monitoring it is now questioning everything they thought they knew about celestial mechanics. A dramatic transformation has struck the object known as 3I/Atlas. And NASA, for the first time in recent memory, has no official explanation. This isn't minor variation or observational error. Within mere hours, 3I/Atlas changed. In brightness, rotation, composition, and even behavior. Astronomers around the world are calling it the most perplexing event since Oumuamua. Let's walk through exactly what happened and why this has sent shockwaves through the entire astronomical community. The sudden shift 48 hours ago, everything looked normal. 3I/Atlas was behaving precisely as expected. A consistent rotation period of 2.4 hours, a stable brightness profile, and predictable spectroscopic readings. Its trajectory was smooth, matching every simulation. Then, within less than a single night, all of that changed. The first reports didn't come from NASA or ESA, they came from amateur astronomers. Multiple observers in completely different countries began noting that 3I/Atlas appeared brighter. Far brighter than it should have been. Not a subtle difference, but a spike so dramatic it seemed impossible. Within 6 hours, the object's apparent magnitude increased by nearly 1.8 points, meaning its brightness multiplied by almost 6 times. In astronomical terms, that's an explosion of light, an event that should take days, even weeks, to occur. Yet here it happened in hours. Comets can brighten due to outgassing, but not at this pace. Nothing natural brightens like that. And when the Hubble Space Telescope tuned in during its scheduled observation window, what it captured only deepened the mystery. What Hubble saw. The images stunned everyone who saw them. Just a day earlier, 3I/Atlas had shown a relatively uniform surface, with faint dust activity and mild brightness variations. But in the new frames, half the object was blazing. Intense emission was radiating from one hemisphere while the other appeared calm. Jets of material, plumes erupted from its surface, reaching out like luminous fingers into the darkness. Within a few hours, the entire appearance of 3I/Atlas had transformed. Whatever happened wasn't gradual. It was instantaneous. But brightness wasn't the only thing that changed. Its rotation, the most fundamental of physical properties, had slowed. Previously, 3I/Atlas spun once every 2.4 hours. Now it takes 3.1 hours to complete a rotation, a nearly 30% reduction in spin speed, with no apparent cause. That's not supposed to happen. In space, angular momentum is conserved. Rotation doesn't just slow down unless an external force, a torque, acts on it. Something exerted that torque. But what? The physics problem. The leading natural explanation would be outgassing torque, jets of vapor pushing against the surface like tiny thrusters. But calculations showed something unsettling. The amount of gas released simply wasn't enough to produce such a dramatic change in spin in so short a time. It would take far more force, far more mass loss than what was actually observed. So if outgassing didn't do it, what did? The deeper astronomers looked, the stranger it became. Spectroscopic readings, the fingerprints of light, showed drastic changes. That mysterious 637 nanometer emission line, the one that appeared months ago during the perihelion explosion and then disappeared. It's back. And this time, it's stronger than ever. Multiple observatories around the world, including Keck, Gemini, and VLT, all confirmed the same reading, a bright, persistent emission that shouldn't exist. No known natural process accounts for it, and yet there it was. Reappearing out of nowhere, something new emerges that wasn't the only anomaly. In the infrared spectrum, new emission bands appeared between 2.5 and 3.5 microns. These wavelengths are characteristic of organic compounds. complex carbon chemistry that shouldn't be forming spontaneously on an inert rock in deep space. Either the surface composition had changed, revealing something buried beneath, or something new was being produced. And then came another shock: heat. Infrared imaging revealed that 3I/Atlas wasn't just brighter, it was warmer. Before this event, the object's temperature was nearly uniform, varying naturally between the sunlit and shadowed sides. But now, thermal hotspots were appearing in regions more than 50 Kelvin hotter than the average surface temperature. That's not solar heating, that's internal energy release, heat coming from inside the object. The fragments begin to move. The debris field left behind by the earlier perihelion explosion, the fragments astronomers had been tracking for weeks, also began acting strangely. Several of these fragments, previously moving on predictable, stable paths, suddenly deviated. Not by much, a few tens of meters per second. But the changes were abrupt, and they all occurred within the same time frame as the primary object's transformation. It was as if whatever affected 3I/Atlas had also reached out and disturbed its fragments. That should be impossible. Once separated, fragments move independently. They don't communicate, and they don't synchronize, unless something connects them. The experts speak out. Dr. Michio Kaku, after reviewing the new observational data, said it bluntly. In 40 years of physics, I've never seen an astronomical object change this rapidly, this coherently, without an obvious cause. He pointed out that natural processes, like sublimation, rotational drift, or chemical transitions, all operate on gradual timescales. But in the case of 3I/Atlas, everything changed at once. Brightness, rotation, spectrum, thermal pattern, and debris motion, all within hours. That's not typical of natural behavior. That's coordinated change. The most troubling aspect, Dr. Kaku said, is the coherence. Multiple independent parameters all shifting simultaneously implies a single cause, one mechanism affecting every property at once. What kind of process could do that? He paused before adding something he'd never said publicly before. I can think of several artificial mechanisms that would produce exactly this pattern. But proposing that without proof is still taboo in science. NASA's silence. NASA released an official statement acknowledging significant unexpected changes in the behavior of 3I/Atlas. But beyond that, nothing. No working theory, no hypotheses, no speculation, just confirmation that the event occurred and that the data is being analyzed. That silence spoke volumes. Ordinarily, NASA offers preliminary explanations, even when uncertain, a cautious, most likely scenario. But not this time. Behind the scenes, insiders describe confusion, frustration, and heated debate. Different teams are proposing wildly different theories, none of which explain everything. Some suggest structural collapse. Others think it was a small, unseen impact. And yes, some quietly whisper about something else: activation. The activation theory. If 3I/Atlas isn't just a natural body but something more, an engineered object, then what we're seeing could be the moment it woke up. If it contains dormant systems, technological mechanisms lying inactive for centuries, a trigger could have switched them back on. A timer, a proximity signal, or even damage from the perihelion event could have initiated activation. That would neatly explain everything. Sudden power generation, causing heat and brightness rotation change from internal thrusters or stabilization systems, emission lines from power sources or sensors. Fragment motion if nearby components began communicating or sharing energy. It's a clean explanation, disturbingly clean. But it also raises a terrifying question. If it activated, what is it doing now? After the initial shock, the global astronomical community scrambled to find answers. Every major observatory, from Chile's Atacama Desert to Hawaii's Mauna Kea, pivoted their attention toward one object: 3I/Atlas. Data was flooding in, photometry, spectroscopy, infrared radar, yet nothing aligned. The event defied conventional physics. It was like watching the universe break its own rules in real time. Let's go through the explanations and why each one collapses under scrutiny. 1. The delayed heating hypothesis. The first idea on the table was straightforward. Maybe heat from the sun had slowly penetrated the outer layers of 3I/Atlas during its close pass, eventually reaching subsurface ice and triggering sudden sublimation. That could cause outgassing, brightness spikes, and even mild torque. But there was a problem. Timing. Perihelion, the closest point to the sun, happened weeks ago. Thermal conduction through a mix of rock and ice is well understood, and models show subsurface peaks would occur days later, not weeks. If this were delayed heating, the event was far too late and far too fast. Heat transfer simply doesn't happen in sudden bursts after a long, quiet period. So that explanation was ruled out almost immediately. 2. The impact theory. Next came the idea of an unseen collision, perhaps a small asteroid or chunk of debris struck 3I/Atlas, triggering the outburst, exposing interior materials and altering its rotation. Impacts can cause instantaneous changes. That's true. But astronomers reviewed the observation logs, and there was no flash, no debris plume, no shock signatures. And multiple telescopes had been watching the object almost continuously. A collision of that magnitude should have been visible. On top of that, the odds of a random high-speed impact occurring right during active observation windows are astronomically small. Possible, yes, but far from likely. And it still wouldn't explain the synchronized temperature rise or spectroscopic anomalies. 3. Structural collapse. The third idea proposed was internal failure. Maybe the object's internal structure gave way under thermal stress or spin forces. Fragments could shift, redistributing mass and slowing rotation. That hypothesis seemed reasonable until the math was done. When comets fragment, their cores usually spin faster, not slower, because mass moves inward. But 3I/Atlas slowed down, indicating mass moved outward. No major pieces were observed separating, no dust clouds, and no significant loss of material was detected. So structural collapse didn't fit either. 4. Exotic ice chemistry. A few research groups suggested something far stranger, that 3I/Atlas might contain unusual chemical ices. Perhaps it holds compounds we rarely see. Ammonia hydrates, methane clathrates, or unknown organics that sublimate violently under sunlight. That might explain the strange emission features, but not the coordination. For 5 separate physical properties, brightness, spin, heat, spectrum, and debris, to all change together, that would require an extraordinary coincidence. As one astronomer put it, it's like 5 different car parts breaking at the exact same second, all for unrelated reasons. Nature can be strange, but it's rarely synchronized. This one wasn't adding up. 5. The electrical discharge hypothesis. Finally, some proposed an electrostatic event. As 3I/Atlas traveled through the solar wind, maybe it built up a strong charge, which eventually discharged explosively. That could, in theory, cause brightening and temporary heating. But the energy required for what was observed exceeded what static charge could produce by orders of magnitude. And radio telescopes listening at the time detected no electromagnetic burst, which should have been unmistakable if this was the cause. In short, every natural explanation fell short. Each theory solved one part of the mystery, but broke somewhere else. None could explain everything at once. The scientific dilemma. At this point, NASA and ESA quietly acknowledged what everyone already suspected. They had no comprehensive natural model that explained the data. Privately, debates turned philosophical. If every known physical mechanism failed to explain what happened, what did that mean? Astronomers aren't conspiracy theorists. They deal in numbers, light curves, and measurable reality, but now, data itself was the mystery. And that's when an uncomfortable idea resurfaced. An idea that had been whispered about since the first detection of 3I/Atlas. The artificial hypothesis. Suppose for a moment that 3I/Atlas isn't a comet at all. Suppose it's technology. If it were artificial, a probe, a vessel, or some kind of autonomous system, everything suddenly makes sense. The abrupt increase in brightness, a power source activating, the rotation change, thrusters or orientation systems engaging, the thermal hotspots, power generation or internal heating, the spectroscopic anomalies, energy emissions or communication signals, the coordinated debris motion, connected components responding to a shared command. With one assumption, that 3I/Atlas contains engineered systems. All anomalies align into a single coherent picture. The problem is that explanation is almost too clean, and it's also scientifically explosive. Extraordinary claims require extraordinary proof. That's the quote now echoing through labs, observatories, and online forums. The phrase, originally by Carl Sagan, defines the fine line between discovery and delusion. Could humanity really be witnessing the activation of extraterrestrial technology inside our own solar system? It's a question that most scientists are hesitant to even voice aloud. But behind closed doors, conversations are happening. One internal NASA source, speaking anonymously, said the mood in their department could be summed up in a single word: uneasy. The data doesn't fit. We're trained to look for natural mechanisms, but this feels orchestrated. Another from ESA's Deep Space Operations admitted, "If I ignore the stigma for a second, the activation hypothesis actually fits better than any physical model we've run." Still, both insisted, evidence must come first. Without direct observation, it remains speculation. The Chinese intercept mission. That evidence may be coming soon. China's Tianwen-3 probe, launched months ago to intercept 3I/Atlas, is now just 60 days away from its target. Once it arrives, it'll deploy high-resolution cameras, magnetometers, and radar systems to map the object's structure down to the meter. If there are manufactured surfaces, cavities, or electromagnetic fields, they'll find them. For now, however, we're left in limbo, waiting, watching, and questioning. Because 3I/Atlas isn't just bright anymore, it's behaving. The coordinated change. The synchronized timing across so many parameters is what truly haunts researchers. Brightness, rotation, emission, thermal profile, debris deviation, all shifting within the same 6-hour window. That suggests not random chance, but coordination. Some form of internal system executing an action plan. Dr. Kaku described it like this: "It's as if a system went through a reboot. Multiple subsystems powering up at once. Light, heat, movement, and emission. Exactly what you'd see if a machine were restarting." The word machine caught the public's attention. Within hours, headlines spread across global media. Did an alien probe just wake up? NASA didn't comment further, and that silence, again, only amplified speculation. Public reaction. For the first time in decades, astronomy was front-page news. Millions of people were suddenly watching telescope feeds, following light curves, and debating orbital mechanics online. The absence of an official explanation created a vacuum, one quickly filled by theories, some reasonable, others wildly speculative. But one fact remained undeniable. Something real had happened, and no one knew why. Across social media, the question spread like wildfire. If this really is technology, what is it doing, and why now? Active experiments proposed. In response to the mystery, some researchers proposed active tests. Send directed radar or radio signals toward 3I/Atlas. See if it responds. If there's a transmission back, even a faint echo that would confirm artificial origin instantly. But others warned strongly against it. "We don't know what we're dealing with," said Dr. Lemaire of the CNRS in France. "Actively probing could be interpreted as interference. Until we understand its nature, we should observe, no, not provoke. It's a debate dividing the scientific world. Engage or stay silent. Observe or test." Humanity has never faced this kind of dilemma before. The waiting game. For now, passive monitoring continues around the clock. Every major telescope, radio array, and orbital observatory with line of sight to 3I/Atlas is watching it closely. Data streams are being analyzed frame by frame. Every spectral spike, every temperature change, every trajectory deviation. If anything happens again, the world will know within minutes. And yet, the most haunting possibility remains the simplest one. Maybe this wasn't a random outburst at all. Maybe this was scheduled. The world's eyes are now fixed on one object drifting silently through space. 3I/Atlas. Whatever this thing is, natural or not, it's changing our understanding of the universe in real time. For the scientific community, this isn't about belief. It's about data. And that data tells a story we've never seen before. The 60-day deadline. In exactly 60 days, China's Tianwen-3 probe will intercept 3I/Atlas. Its instruments will map the surface in high detail, scan for magnetic fields, analyze spectral emissions, and probe the object's internal composition. Those results could end the debate once and for all. If the data reveals structured geometry, metal alloys, or non-natural radio patterns, humanity will face the single most profound discovery in our history. Until then, astronomers can only watch as 3I/Atlas continues to evolve. Every hour, new readings come in. Every day, its story deepens. And yet something feels coordinated. It's as if this object is waiting. The split between scientists. Behind the scenes, scientists are quietly dividing into two camps. One side insists this is natural, just an extremely rare convergence of cosmic processes. The other believes we may be witnessing the activation of an ancient probe, something built long before humanity's first tools ever struck stone. Dr. Kaku described it bluntly. If this is artificial, it changes everything, or not just astronomy, but history itself, because that means we were never alone. We were simply not yet interesting enough to notice. But even he cautions patience. Extraordinary claims demand extraordinary proof. What happens next? The next few weeks will be the most closely monitored period in the history of astronomy. Dozens of telescopes from Hubble to Webb are trained on 3I/Atlas every night. Teams are analyzing every pixel, every photon, every emission line. And yet, for all our technology and knowledge, there's an eerie helplessness. We can observe, we can theorize, but we can't control whatever's unfolding out there. The last time something this mysterious entered our solar system was Oumuamua in 2017. And we never got the answers we wanted. This time, though, we might. This time, we're ready. The final thought. Whether 3I/Atlas turns out to be a natural anomaly or a relic of alien technology, one truth stands above all. It's rewriting what we thought was possible. If it's natural, we've just discovered physics no one's ever documented. If it's artificial, we're witnessing contact. Not through words, but through observation. Either way, the universe just got a lot more interesting. And in 60 days, we'll finally know the truth.